Now that we've completed the superstructure, let's now see how to define the foundation or substructure. First thing is to go to the foundation level. Here we find the columns visible in the background layer. These are a projection of the columns present at ground floor level. From the design menu, I'll grab the beam object and in the properties toolbox under the characteristics section, I'll select the most suitable profile. I'm going for the inverted T-section type foundation beams, and in the properties section, we'll specify the ground type and the physical and geological characteristics. When starting a project, the structural engineer must add the necessary data, as obtained from the geotechnical study, in the soil archive to represent the different soil stratifications and therefore its mechanical and physical data properties. Returning to the foundation level, I'll continue to add the other beams, but I can still use the same method as before, copying the generic superstructure beams from the ground floor level. Using the copy function again and set the ground floor beams as our source beams to be copied to the foundation level. This now means that we have the same beam section type at foundation level 2, but we can then keep them selected and change their profile type to the inverted T-beam type. Specify that they are foundation beams and associate the ground type. As a surface foundation, we can also model a foundation slab. From the Objects menu, simply select the parametric object foundation slab. In the Properties box, define its thickness, the soil type, and then simply model the slab shape. In addition to defining the soil characteristics, in the Properties toolbox, under the Geotechnical section, we have the Limit Load subsection. In this subsection, regardless of the type of foundation, we also need to provide the necessary information to perform the calculation of the load-soil ratio limit, therefore specify whether the behavior is coherent or non-coherent, or ultimate limit state of soil resistance, the behavior of the soil and the draining conditions of the soil. For superficial foundations, the program also takes into account the subsidence calculation. In the navigator, under Calculation Preferences, and in the specific section for foundations, we can activate the calculation by clicking on the relevant flag. In addition to the modeling of the superficial foundations, EdiLus also allows us to model deep foundations, with the parametric foundation poles element useful to define our foundation slab. If we select the foundation pole element, we can add these structural elements, and in the Properties box, we can associate the soil stratigraphy composition. Even in the case of superficial foundations, we still need to define the soil layers. Let's see how it is possible to define a stratigraphy. In the Elements navigator, we find the Terrain or Soil Stratigraphy section. As already seen, in the library we have various examples of stratigraphies. The structural engineer must add the stratigraphy of his structure. To do this, it gives it a name, for example, Custom Stratigraphy, and it must define the number of layers of which the soil is composed. In each layer we must specify the type of soil, such as the thickness, the behavior of the layer, and this for each layer of our soil. The definition of stratigraphy is fundamental when we have foundation pilots or surface foundations on which we have to calculate the seats. Once the stratigraphy is defined, the pilot object is selected and the Properties toolbox assigns the custom stratigraphy that we added to the file. In the case of a foundation slab, we are free to design pilots in the position we want. It is also possible to model another type of foundations on poles, such as Winkler beams with poles or even skates on poles, which we can already find as a parametric object in the Design menu. We can choose within a fairly large file different types of skates with poles, assign a stratigraphy, and see that we can use an automatic generation from pillars. Then through a simple selection, we model on each beam a shoe with poles. We complete the structure of the foundation with a simple connecting beam. These beams will simply have the function of connecting the skids, while the structural function will fall on the skates with the pilots.